Use the graph of the function to find all key features. I'm going to begin by grabbing the x-intercepts. Now here I have 4 x-intercepts. Those are all of the values that are on the x-axis. So here we have -3, -2, and -1. We also have a +1. Now if I write them as coordinates, all of these values are at 0, so my first x-intercept is -3, 0, followed by -2, 0, and then we have -1, 0, and +1, 0. So here I have 4 x-intercepts. Now the y-intercept is where the graph crosses the y-axis. The y-axis is again this vertical line, and we can see that my graph crosses at the point -6. So at 0, -6. All right, so let's see. Now we want to look for the maxima. So the maxima, I really mean local max, the peaks of the graph. And you can see that here we have this peak at the point -1.509. And that's the only peak that we really see within this graph. Now the minima is very similar, but this time we're going to get the low points of the graph. If we look at the function, we can see that that happens at 2 places, right here and right here on the right. So here, my local max is, or my local minimum is at -2.6, -1.4, and my second value, or my second minima, is going to be from, or at 0.3, -6.9. Finally, we're going to look at the end behavior. So as x approaches -infinity, so as my x values keep getting smaller, 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 you can see that we're going to approach this x value of -3. On the other hand, as x approaches +infinity, as my x values keep getting larger and larger and larger and larger, you can see that this function is increasing. Since it's increasing, it's going to go all the way to +infinity. So here, as x approaches infinity, f of x approaches infinity as well.